we will look at question number 1C of UPSC Physics Optional 2013. So the question number 1C says the following, that show that the particle of rest mass m0, the rest mass of the particle is m0, total energy of the particle is E, and linear momentum of the particle is P vector, and this particular particle satisfies this particular relation. Okay, E square equal to C square P square plus m0 square C to the power 4. So this particular fact we have to prove that any particle which has the following entities, that rest mass m0, energy E, and linear momentum P vector. So every particle satisfies this particular relation. This is what we have to prove. And over here C is the velocity of light in free space. What is C? C is the velocity of light in free space. Okay. So this is UPSC 2013 Physics Optional Paper 1 question 1C. So let us look at the fact that how we need to solve this particular question. Let us look at it. So E square minus P square C square. We will move on in the following manner, that E square minus P square C square. Then we will write E equal to mc square by Einstein's mass energy equivalence relation. What do we have? By Einstein's mass energy equivalence relation, E equal to mc square. So E, instead of E we will substitute mc square. Okay, so E square, instead of E we will substitute mc square, and then mc square will be squared. Okay, and what about P momentum? P momentum will be written as mv. P momentum will be written as mv, and we will take its square. Okay, and C square is as it is. So E is equal to mc square and P equal to mv, you all know already, right? E is equal to mc square is by Einstein's mass energy equivalence relation, and P equal to mv is the fact that momentum is equal to mass into velocity, which we have been learning since lower classes. So we substituted these two values in this expression. So what do we get finally? Finally m square will come, C to the power 4 will come, m square will come, v square will come, and C square will remain as it is. Then we will take out m square C to the power 4. What do we do then? What to do next? What to do next is that m square C to the power 4 will be taken common from this expression. So m square C to the power 4 has been taken common, and 1 minus v square by C square is there in the bracket. Okay, 1 minus v square by C square is there in the bracket, and m square C to the power 4 is there outside of the bracket. Okay, so what to do next? In the place of m we will substitute m0 square divided by 1 minus v square by C square. How did we substitute this? First of all, we took m square C to the power 4 common from this, and this term we got in the bracket. Then instead of m, the rest of the things we have kept as it is. All these things we have kept as it is. Okay, all these things we have kept as it is. Only instead of m square we are substituting this particular value. Now what is this particular value? This is the mass of the particle at velocity v. What is m? M is the velocity of the particle. Let me write. M is what? M is mass of particle at velocity v. Okay, so you already know that according to Einstein's theory of relativity, the mass of the particle varies with velocity. Mass of the particle varies with velocity. So at velocity v, the mass of the particle will be m0 square divided by 1 minus v square by C square. This is what will be the mass of the particle at velocity v, where m0 is the rest mass of the particle. Okay, so then what to do? This 1 minus v square by C square and 1 minus v square by C square will be cancelled from here. You can yourself have a look that this particular thing and this particular thing will be cancelled from here. So what do we get finally? m0 square C to the power 4 is the term which we get finally. Okay, so instead of m, what did we substitute? Instead of m we substituted, what did we substitute? Instead of m we substituted m0 divided by square root of 1 minus v square by C square. This is the mass of the particle at velocity v. This is what? Mass of the particle at velocity v. And m0 you already know. What is m0? It is rest mass. And m is what? Mass of the particle at velocity v. m0 is what? It is rest mass. So instead of m we have substituted m0 divided by this much, and when we took its square it came out to be like this. Then this particular entity 1 minus v square by C square and 1 minus v square by C square, those two terms got cancelled, and finally we got m0 square C to the power 4. Finally what we got? m0 square C to the power 4. And E square minus P square C square is equal to what? Now have a look. E square minus P square C square is equal to m0 square C to the power 4, right? So E square will be equal to what? E square will be equal to P square C square plus m0 square C to the power 4. What will be E square? E square is equal to P square C square m0 square C to the power 4. This P square C square from the left hand side will move to the right hand side, and it will become plus. After it is minus over here, it will become plus on the right hand side. Okay, because as we change the side, the sign also changes. So basic algebra. So E square equal to P square C square plus m0 square C to the power 4, and this relation is called as relativistic energy momentum relation. This relation is what? It is relativistic energy momentum relation. Okay, so in this way, question number 1C 2013 physics optional paper 1, okay, solved successfully. You can have a look at the playlist which is coming as end screen. In the end screen of this video, one playlist will appear. In that playlist, question 1A and question 1B have been solved. Tomorrow we will have a look. Tomorrow we will have a look at question 1D. So thank you very much.